Hi, and welcome to our last lesson in Chapter 2. We're going to spend a couple of days here talking about the normal distribution in a more formal approach than we have previously. Before we've said that it has the bell-shaped curve condition. That's why it looks like a bell-shaped curve, that it's symmetric about the mean, and also that the median and mode are at that point. We've said that the total amount of data in almost all normal distributions will be contained within 3 standard deviations below the mean, contained in an interval, 3 standard deviations below the mean to 3 standard deviations above. And as you look over here at this picture of the standard normal curve, you'll see that we've added a mean of 0 here. The variable along the horizontal axis is a z variable. That stands for the number of standard deviations that some data point is away from the mean. So, as we've said, almost all of the data in a normal distribution will fall between -3 and +3 standard deviations of the mean, and that's the way we've got that standard normal curve marked up there. So this is a standard normal distribution. The horizontal variable is called a z-score, and what that stands for, again, the number of standard deviations that some data value is from the mean. Folks, this distribution has been studied all over the place because many things in nature act this way, where lots of them cluster around a central measure, but some are at lower end and some are at higher end. So that distribution is totally symmetric, which makes it nice to work with. And the total area under this curve is equal to 100% of the data in theory, or another way of saying that is 1 if you move the decimal point 2 places. So we can, since this has been studied so much, tell with pretty good precision what proportion or percentage of a data set will fall under a given z. Say we were here at -1. We can tell what part of the area of the curve, or what is the proportion of data values that are less than or equal to. Another way to say it is, what's the probability that a data value would fall at or less than 1 standard deviation from the mean. All of those can be told using a z-table. This table is in the inside back cover of your book, and I will also make sure that you get a paper copy of it. The way the table is set up, z-scores are the designation here at that leftmost column. So each row here talks about a z-score. The columns are hundredths. If you'll notice, these go to whole point tenth. So if we wanted to know about the probability that some data value lies at or below -3.54, we'd go to the -3.5 row and look in the 0.04 column, and we'll see that there's only a 0.0002 probability that that could happen. Our table shows negative values of z as well as positive. The positive are on the facing page, but you can tell just by looking at this graphic, again, when you read a value from this table, you're getting the probability that we get some data element that lies at or below the z-score where we're at. Okay, now what I'd like us to do is get a little bit of use out of this table, so we're going to use it a little bit. And we are going to find the proportion of values that are less than a z of 1.35. I've moved the page in the table to be at, so that we can see the positive values for z, and we need 1.35. So here's the 1.3 row, and we want to move ourselves over to the 0.5 column. So the probability that we would find a data value that lies at or below a z-score of 1.35, according to the table, is 0.9115. 0.9115. So There you have it. We found the probability that we could get a z-score lower than 1.35 about 91% of the time, looking at that probability. Now, I said probability, I said proportion, I could also say percentage. All of those things mean the same thing, and we have some practice here working with that z-table. So we're going to ask you to get your table out or look at mine. We want to know about a z less than negative 2.23. So we got to get on the negative side of the table. And what we were looking for was negative 2.23. There's negative 2.2. 0123. There it is. 0129. 0129. Good. It's helpful to remember what you're looking at there. When you say that you want that z to be less than negative 2.23, remember the 0 mark is right in the middle. So we're talking about somewhere way out here. We want to land in that shaded area, and our chance of doing that is about 1.3%. Okay? The next of these problems for us asks us to look at greater than, and now we're going to really ask you to think about what it means, that whole z-score thing. Greater than 0.8. Well, that's a positive number, so we know that it's going to fall out here in positive land somewhere. And we want the probability that we land greater than that. Well, see, our table doesn't show greater, it shows less than. Here's where we have to remember. The total area under there is 100%, or 1. Okay? When we look up the z-score of 0.8 on our table, it's going to tell us the area underneath. Right? That's not what we need. But together, what we don't need and what we do need add to 1. So if we want to find what we do need, we're going to have to do 1 minus the probability that z is less than 0.8. Or we're going to go to our table, look at 0.8, and we're going to subtract whatever it says from 1. 0.8 is on the positive side. 0.8 right there. 0.7881. That's the probability that you would go underneath that z-score. 7881. Our problem, remember, wanted us to get above it. So we have to do 1 minus 0.7881. And I should probably be able to subtract that, but I'm going to go to my calculator. And I want 1 minus 0.7881. Okay, 2119 is that probability. About 2119, or 21% of the time, we'll reach a value that is a z-value that is larger than 0.8. All right, our next example problem, we should be able to answer without the table, folks. The 0 mark is right there, and the probability that we hit a z less than 0, since this is totally symmetric on both sides, it's half of 100%, or there's a 0.5 chance that we will land to the left of the mean. Our last problem, folks, I want to draw again here because I think this is really important for us to get the understanding of what it is that we're looking at. We want to know the probability that we land at the z-score between -1 and +1. So somewhere in between here. And I would ask you to think about this. When we look at our table, we can find the probability that we hit at less than 1. That's right here. But that will tell us all the way down. We don't want all the way down. In fact, we want to stop when we get to -1. So to find this, folks, we are going to take the probability that z is less than 1 from the table, and we're going to subtract from it the probability that z is less than -1. Okay? We want, remember, when we find this guy, the high one, that's going to be all of this, but we don't want all of it. We only want the part that's above here, so we're going to subtract here. So we got to remember two z-score values from that table, 1 and -1. 1, +1, 8413. 8413, and negative 1, 8413, and there it is, 1587. 8413, 1587. All right, here we go. 8413, 1587. And let's do that subtraction. 0.8413 minus 0.1587. 0.6826. 0.6826, so about 683. Ladies and gentlemen, that's kind of important. Between -1 and 1 standard deviations from the mean, about 68% of the data is there. And you'll recall we spoke about that in a previous lesson. All right. So now we're going to work backward from the z-table. We have a probability that we're interested in, and we want to know which z-score would correlate with that. So if we are given a probability, we are going to look in the body of the table and get as close to that percentage, 0.32, as we can. Then we will read out and up to find what z-score correlates with it. So here we go. 0.32 is what we're looking for. In the body of the table, oh, I'm on the negative side, so I should be good there. 0.32 is what I am looking for. Oh yeah, I see it. It's coming right in here somewhere. Oh, right here. Right in between here and here. 3192 is the closer of those. So we are in the -0.4 row, -0.4, and we're 0, 1, 2, 3, 4, 5, 6, 7. -0.47 is that point. And I'm going to -0.47 right in there. So the z-score that we would need is -0.47, about. That's as close as we can get to 32%. I'm going to ask you to do that a couple more times. I'll do it without talking. You can pause the recording if you would, and then check your answers against mine. 0.87, right in there. 8708 is the closest we can get, and that is 1.13. Now we want to get 0.06, and we want to be bigger than that. So in order to be bigger, since our table only shows us smaller, we're going to have to find 0.06 up here. That means that 0.94 is unshaded. We need the z-score that traps that 0.94. 0.94. It's right in between those two. 0.94. I'm going to go with the smaller of the two. Some people would say you should go directly in between, which would be 1.555. I'm going to go with 1.55, and that means I have, actually this is the one I want, that guarantees 94% underneath it. So it's 1.56. The z-score of 1.56 guarantees that at 94% is saved below. All right, we're going to talk now about standardizing a distribution, and that just means that in real life we want to be able to change data values into z-scores. That's just telling us how many standard deviations above or below the mean something is. So to find a z-score, you take the distance from the mean. Folks, that would be data value x minus x bar, which stands for mean, all divided by s. That says take the difference from the mean, divide it into a number of standard deviations, and that's exactly what the z, or the standard normal curve, shows. Now I have that formula for z. You can see that it depends on knowing a data value, an average, and a standard deviation. If I wanted to solve that for x, so say that I know what the z is, but I have to find the x, we could work backward in that formula to do that. To get x by itself here, you'd multiply z times s, so z times s, and then you'd have to add the average. There's a formula that will allow us to find a data value knowing a z. This formula allows us to find a z knowing a data value. Both very important, and we're going to use both of them. If x bar is 550 and s is 100, it says find the z-score for x equals 600. Well, if we're finding z, formula says that we take the data value, x, we subtract the average, and we divide by the value of a standard deviation, which is 100 here. 600 minus 550 is just 50, and 50 over 100 is 1/2, or 0.5. So the z-score for this situation is 0.5. Same criteria, same average, same standard deviation. Find an x if the z-score is negative 0.45. So now we need to have an x thing given a z. So x would equal negative 0.45 times the standard deviation plus an average, and the average was 550. I think we can do that math in our head. 45 times 100, that's going to be negative 45. Negative 45 plus 550 would get us to a data value of 505, if I did the subtracting right, and I think I did. So we've used the formula both directions, and we are ready now to put it all together. I'm going to remind you of those formulas. Z is equal to data value minus average over standard deviation. If we need to find a data value, we do that by multiplying z times standard deviation plus mean. All right, the heights of males aged 18 to 24 has a mean of 70.1 inches. Here's our x bar. And a standard deviation, here's our s, of 2.7. Find the probability that a randomly selected male in this age range is taller than 70. If I were going to write that statement, I want the probability that z is greater than, and then I have to think, whoa, we don't have a z yet. We have a data value here, x. So we need to find a z. And we're going to say z will equal 70, that's our data value, minus the average over the standard deviation, and that would be negative 0.1 over 2.7, negative 0.1 over 2.7, z-score of about, now see the z-table, it goes by hundredths, so 0.04, should be negative 0.04. I didn't get my negative sign on there. Negative 0.04. And the hundredths is the closest we can come. So we want the probability that a z-score is larger than negative 0.04. Folks, that should be greater than 50% if you picture what this is saying. We want to be greater than this. So I remember from the previous work, that this is a subtraction problem. Remember, we need to be above, and together the part that we can get on our table plus what we need equals 1. So we want to go 1 minus the probability that z is less than negative 0.04. So there's a statement of what we have to do. All we have to do now is look up what z-score is associated with negative 0.04. So negative 0.04 is the z we're looking for. Negative 0.04, negative 0.0, 1, 2, 3, 4. There it is, 4840. 4840. All right, so 1 minus 0.4880. The probability then that we're going to get 1 minus 0.4880. 0.512. So there's about a 51% chance that if you pick a boy at random, a male at random, between the ages of 18 and 24, he's going to be taller than 70 inches, which is about 5'10". So about half of the time, you're going to get somebody taller than that. Here's one about female height, same kind of process. The average is 64.8 inches for women. Standard deviation is 2.5, and we want the height that 35% of females fall below. Okay, we want a height. And so that's an X. We need the X this time. And we want 35% of females to fall below. Well, 50% is the halfway mark. So we're talking about some negative z-score out here. And I don't know what the z is, but I do know that the area is 0.35. So this is going to be one of those situations where I have to look in the body of the table for as close as I can get to 0.35 and then use that z-score. 0.35. Boy, we're right in there. It's right here. In fact, 3520, 3483. 3483 is closer. So negative, the z-score is negative 0.39. Negative 0.39. Negative 0.39. All right, so not a question mark anymore. Okay, so now we want to find the data value. We have the z-score. We're going to use the formula here. X will equal, our z was negative 0.39, our standard deviation 2.5, the average height for women 64.8 inches. And I'm going to let my calculator do that work for me. Negative 0.39 times 2.5 plus 64.8. We're looking at 63.8 inches, about 63.8. So the 35th percentile for a woman's height, that is the height where 35% of females are at or below, is 63.8. And ladies and gentlemen, I am in that shaded part. Okay, I'm shorter than 63.8, so I'm less than the 35th percentile in height. All right, I hope we've given you a lot to think about today. Okay, we're going to ask you to watch again if you need to. We want you to look at the U-Try tonight. If you need to watch the video again to help you answer the U-Try question, please do it. Okay. All right, we'll see you in class tomorrow.